Hi friends, we are supposed to prove that CD equals to AB, and actually this question we are going to do it by using Chord properties. So Chord properties of cycles will guide us actually to solve this question. And one of the property of a chord, dear friends, is when you are given a cycle and this is a center, you have a chord here. As long as the chord is passing, as long as we have perpendicular bisector passing through the center, so this is center O, so this part is equal to the other part. So it means the chord is divided into two parts. So that is the property actually we are going to use in this question here. So by using chord property, if I'm going to consider this cycle A here, let me call it cycle 1. Okay, so we are going to say that AXC is equal to XCD. And the reason here, dear friends, is XC is the middle point because we have perpendicular bisector. So perpendicular bisector theorem. So that is cycle number 1. And when you consider cycle number 2, we are going to say that BXC equals to XCC. The same reason, because we have a line passing with perpendicular bisector passing through the center, so the chord is going to be divided into two equal parts because we had perpendicular bisector. So now we know that AXC, actually AXC can be opened further. We are going to say that AXC is AB plus BXC, and also XCD is equal to XC plus CD. So by using equation number 1, by using this equation 1 here, we are going to simplify further. So we're going to say that actually AXC, it is AB plus BXC equals to XC plus CD. But we know that BXC equals to XC. So it means BXC can be cancelled here, and eventually we are coming to the point where we can see AB equals to CD, dear students, dear friends. So it is proved already. The secret point to approach this question is by using Chord properties of cycles, that actually we have been taught that perpendicular bisector of a chord passes through the center of the cycle. It is true, and that perpendicular bisector divides the chord into two equal parts. We continue with the second question. So the second question, question number 10, is it has been as you can see, from the question here, we are supposed to prove that AB equals to 2 over 3 square root of 3 L square minus H square. So for this question, we are going to use another property. Again, called properties of cycles. So if you are having a cycle like this one, two intersecting chords, Okay, so you have A, B, C, D, for example. Okay, so if this is A, B, C, D, the unit of these distances, so actually the product, understand that so if this is our intersection point, according to intersection theorem, AX times XB equals to DX times XC, dear students. So now we are going to manipulate this cycle, so that we are going to have two intersecting chords, and from here the intersecting chord we are going to call this intersection point here XC. We are going to say that actually DXC you multiply by XC is going to be equal to AXC multiply by XB. Understand that AB is going to be 2XC, okay? AB is going to be 2XC. So we're going to do mathematical operations. For we to avoid confusion, I can call this point here maybe C. Now there is C. I can call this P, Q, R. Yeah, I can call this R. So that here we are going to have different approach. We are going to have now dr being multiplied by rc. This is going to be equal to ar multiply by rb. So the hint is AB to be 2x, and now we are going to see how we are going to manipulate the equations, this product here, so that at the end we are going to get 2x, and 2x will be AB. And so if AB match the given equation above, then we can say that we are done. So let me start with dr. dr, it is 2x plus L, okay? And RC, mind you, P is the midpoint of DC, so it means RC will be actually 2x minus 2x minus 2x minus L, okay, because this is L, so PC is going to be 2x, also it will be 2x. Now RC will be 2x minus L. Coming to AR will be again, you have XC, here you have H, so it will be XC minus H AR, because Q is the midpoint of AB, okay? So AQ is going to be XC, and here we have H, so it means now AR is going to be XC minus H. What about RB? RB is going to be XC plus H. So now we are going to go back, substituting these values to this equation here. So now you have 2x plus L times 2x minus L equals to x minus H multiplied by x plus H. Remember difference of two squares. If you have a square minus b square, this is equals to a plus b, a minus b. So this expression here now will be 2x square minus l square equals to x square minus h square. We simplify further, so you have 4x square minus l square equals to x square minus h square. Now we're going to make x the subject, so we have 3x square equals to l square minus h square. Mind you, we are looking for 2x, okay? We are looking for 2x, which is equal to ab. So we can manipulate now this expression here so that we get 2x. From the expression you can see x square is l square minus h square over 3. So I can multiply by 4 both sides. I can say 4x square equals to 4 l square minus h square over 3. Okay, then from here I'm trying now to compare actually the value we were given in the equation. You have 2 over 3. So I'm going to now to manipulate the equation so that eventually I'll be getting 2 over 3 out of the square root. So you can multiply here by 3. You can multiply here also by 3, so that you have 4x square equals to 4 times 3 times in the bracket l square minus h square over 9. And now we are going to introduce the square root. So 2x, dear students, will be 2 over 3 square root of 3 in the bracket l square minus h square. But 2x is b. 2x is b, and b, sorry, is ab, and ab is 2 over 3 square root of 3 l square minus h square. And that is how we were supposed to show it. So you can say hence shown, dear students. Thank you. So if you want to get ideas on how we are solving these kind of questions, of course, be alerted on the coming content by subscribing to the channel. I wish you all the best in your learning journey. Peace.